I want to welcome all of you to the Valley of the Shadows of Correlation and Regression. Correlation and regression. We're going to dig deeper into this. So let's start briefly. What is correlation? I want each one of you to give me a synonym for correlation. Who can give me a synonym for correlation? Any synonym that you know for correlation? Which word comes nearest in meaning for correlation? Sam.
Yes, sir. Good evening, sir. Thank you. I think connection or association. Yes.
Association. Good. Connection, association. What else? What else? Prince.
Something which aligns to something.
One
So
word.
alignment. Alignment.
Alignment. That is only okay. I want a real synonym for correlation. Nexus. Esther.
Prof, interdependence.
Interdependence. That's good. Linkage. Linkage.
Relationship.
Reciprocity.
Well, I'll buy relationship, not reciprocity. Okay. So correlation is an association between two variables. Association, particularly a linking relationship. And correlation is an interesting word because there are so many things that are correlated. And when you get to know those things that are correlated, you are able to now draw some inferences from them. For example, correlation can be strong or weak. Which one is stronger? A brother and a brother and a sister, or let's say a brother and a sister and then cousins. Which one is more likely to be strongly correlated? Which one?
The brother.
Brothers.
Brother and sister and cousin.
Exactly. The correlation can also be positive or negative. What do you think is a correlation between consumption and income? Is it positive or is negative? I'll ask you why. So before you give the answer, think about the why. What is the correlation between a brother and a sister? Sorry, I mean between consumption and income. Consumption and income. That is positive. Because if your income is high, your consumption is high. Between price and quantity demanded, that is negative. Because the higher the price, the lower the quantity demanded. The relationship that you see on your screen, is it positive or negative? It's positive. The relationship that you see on your screen, is it positive or negative? It's negative.
Negative.
So you can actually talk about relationship being positive or negative whilst you are looking at the percentage value. You see, there is a statistic that is used to determine whether a relationship is positive or negative. And this statistic is known as the Pearson's product moment correlation coefficient. The Pearson's product moment correlation coefficient, write it down. It is between -1 and +1. -1 means that you have a perfect negative relationship. +1 means you are a perfect positive relationship. 0 means there is no relationship. However, the absolute value of the correlation coefficient is more important than just the number. So let me ask you, which of these two I'm about to write is exhibiting a strong correlation? You have this, and then you have that. Which of these two is exhibiting a strong correlation? Who can tell us? These two values shows a strong correlation? Is it the first one or is the second one? Bernard?
The first one.
Why?
Because the sign, we don't take the sign into account when we are looking at the value. We only look at the value.
Very good. Very good. Okay. You have this in your exam, so take notes. So let's move on now and go to these graphs here, Bernard. These graphs that you see here, okay, what is the relationship for the one I have circled? What sort of relationship is being exhibited by the graph I have shaded? What is the relationship there? Who can tell us? What is that relationship? Sam?
I think it's a positive relationship.
It is a positive relationship. 2 marks for you, Sam.
Thank you. Thank you.
Is the class rep here?
Yes, sir.
Mary, okay.
Please write his name and put 2 marks there so that I can use that in his continuous assessment. What is a relationship that is exhibited here? Okay, on this section. What relationship is that? What relationship is that? Sam?
It's a negative relationship.
It is a negative relationship. How about this one on the top right here? What relationship is that? That's tricky.
So I think we can say that it's a negative and positive relationship.
What do we call a relationship that is both negative and positive? There's a name for it. Starts with Q.
Quadratic.
It is quadratic relationship. What is a relationship that is exhibited here? It's a logistic relationship. I'll give you these also in the exam, so take note of that. Now let's go to regression. Regression is beyond correlation. Correlation is about association. Regression is about causality or cause. Regression is about causation. Correlation is about association. Now, sometimes some people confuse correlation with regression because they look at some relationship and they think that it is exhibiting regression or causality, when in reality is not representing causality at all. Let's take an example. During Christmas period, do the demand for foodstuffs at Makola go up or they come down? Demand for foodstuff at Makola during Christmas, do they go up or they come down?
They go up.
To go up. So.
Okay. Now, do demand for food at the restaurant go up or come down?
They go up.
It's also go up.
Are these two events correlated? Are these two events correlated?
Yes.
Do these two events exhibit causality or causation?
Yes.
Sorry?
Yes.
Okay. So while these two events are correlated, there is no causation. There's no causality. There's no regression. You see, causality happens when you believe that one is the one that is causing the other to go up or to come down. For example, we spoke about income goes up, consumption will go up. So the rise in consumption is as a result of the rise in income. That means the income is causing the consumption to go up. However, there is nothing about the restaurant that is causing anything about the foodstuffs in Makola demand to go up. Neither is there anything that shows that because demand for foodstuffs in Makola is rising, that is also the reason why that of the demand for the restaurant food is rising. It is not the macula one that is causing the restaurant one to go up. They are both being rather caused by something outside of both of them, and that is the Christmas season. So, guys, correlation does not imply causality. Discuss. Understand that until you see it somewhere in an exam. Now, let's go to regression properly. Let's try to understand regression, also called causation or causality. Regression is a technique, just like ANOVA is a technique. Regression is used to establish the causal relationship. Take note. Correlation is used to establish the relationship, but regression is used to establish the causal relationship. You see, a regression will have a left-hand side as well as a right-hand side. Okay? The left-hand side is known as the dependent variable. Write them down, write them down. The right-hand side is known as the independent variable. One of them is influencing the other. Which one is causing the other to behave? Who can tell us? Is it the left-hand side that is causing the right-hand side, or is the right-hand side causing the left-hand side? Which one is a cause? Which one is a recipient? Bernard.
I think the right is what is causing the left, because the right is independent and the left is dependent on.
Excellent. Good judgment. So Bernard, I've got 2 marks also for you because of the extent of your contribution.
Thank you, sir.
To the body of knowledge. Class, please take note of that. So the independent variable is that variable that is the causal agent. The dependent variable is the recipient agent. The independent variable has another name. The dependent variable also has another name. Who can tell me another name for the dependent variable and its corresponding independent variable? Who can tell me? Who can tell me another name for the dependent variable and its corresponding independent variable? What is another name? The dependent variable is also called outcome. And the independent variable is also called predictor. It's always been in front of you all this while. The dependent variable is outcome. The independent variable is predictor. Who can tell me another name for the dependent variable and another for the independent variable? The dependent variable is also called explained. And the independent variable is also called explanatory. Explanatory. Who can tell me another name for the dependent variable and another for the independent variable? Some.
Predicted variable. Oh, yeah.
For which one?
Predicted variable for the dependent variable, and independent variable, we can say predictor variable.
That's good. So the predicted is the dependent and the predictor is the independent. Another name for the dependent variable is target. This is normally used a lot in machine learning. Target variable. And its corresponding independent variable is known as features. See, if you were not writing any of these things we've been talking about these past few minutes, you are in trouble somewhere. Okay. So it's very important that you are documenting everything. Now, when the dependent variable is always one. Keep the dependent is always one. When the independent variable is also one, what kind of regression are we talking about here? simple regression. Simple regression is where the dependent is one, independent is one. In a multiple regression, the dependent is one, the independent are many. They are many. But the independent variables are numbers. Okay, I'll be giving you an example right now. The independent variable are numbers. They are numbers. But when some of these independent variables are not numbers, they are categorical. When I say numbers, I'm talking about numerical. But when some of them are not numbers, they have gender, they have other things, they have occupation, they have religion, they have that. When these independent variables are not numbers, we now call the entire regression dummy variable regression. Dummy variable regression. If you look at education and income, which one is the independent variable? Education and income. Which is the independent variable? Education and income. The independent variable is in education. And if you look at income, student grades and hours of work, student grades is the dependent variable. Okay, let's proceed. So we are now going to look at a simple regression. And your job is to be able to understand the elements of this model. This is a simple regression model, the first one here. What is a model? A model is a representation of reality. Write it down. A model is a representation of reality. You can manipulate a model, but it's not easy to manipulate reality. You can build a model of a house and change it and move it and do it a 3D version. You can alter it. You can alter it. You can alter it. But then you cannot easily manipulate a physical building. It's not simple. So models are needed to represent reality. This is a simple regression model. It has 4 parts, and you should know all the 4 parts. The left-hand side of this simple regression is known as the dependent variable. It is a recipient. It is the one being affected. For example, suppose there is a disease, and that disease is being affected by other things. The factors that are driving the disease upward or downward. That is the left-hand side. It is a predicted variable. Now, the other variable is the right-hand side variable known as the x. The x is the independent factor. It is the one doing the influence. It's the one causing the dependent variable to behave the way it is behaving. But the question is that by how much, write it down, by how much does the x affect the y? I wanted to see the x like, steady time. Look at the one here, okay? Like, I wanted to see the x like the steady hours, the steady time. Okay, that's the x, the steady time. The hours you put in to learn this course. And the y is the grade you get. So if you are going to get A, how many hours do you think you got to put in to get A in research methods? How many hours? How many hours do you think you got to put in to be able to get A in research methods? Look at this. Or looking at your life now. How many hours? Well, my advice is that you put in at least 4 hours a day. At least 4 hours. Okay? You should do that. Put it at least 4 hours on all your courses. In fact, I would suggest that you do 8 hours equally. Equally, because your regular MBA students are doing a similar thing. It's 8 hours. You have 24 hours a day. You do 8 hours on your job. You sleep like 6 hours. you do like 8 hours, okay? But at least 4 hours. You should do that and spend on your modules. Not only one, all of them. So what is the beta? This beta here is the marginal effect of the X variable, which in our example is the hours of study. So this is the hours of study, and this is your grade. So if I were to write this practically, okay, you have the grade being on the left-hand side. So if I were to write it practically, it's going to be something like grade, okay, it's a function of beta naught plus beta 1 hours of work plus UI. Okay, but normally you should have grade I and then hours I. So that is what we mean by a model, a simple regression model. In other words, the hours you put into the learning is going to affect your grade. So hours is an independent variable, grade is a dependent variable. And by how much does hours affect grade is given by the beta value attached to the hours. Okay, so this is known as the marginal effect of the hours on the grade. Now we are left with this beta naught, or this alpha in this example. What is that beta naught? Beta naught or the alpha has no economic interpretation. Write it down, please, write it down. The alpha has no economic interpretation. The alpha is for cosmetic purposes. The alpha is for cosmetic purposes, and sometimes, even in Excel, you can suppress it. You can choose not to show the value of the alpha. That is how unimportant it is. How less important it is. However, alpha is only important mostly when you're doing prediction. Alpha is very important when you're doing prediction. Never forget that in life. That leaves us with the most important thing in this whole regression model, and that is the error term. The error term. The error term talks about all other factors that can affect the dependent variable, but haven't been captured. Every other factor, okay, but has not been captured inside. So I just spoke about hours of work, as if hours of learning is the only thing that can affect your grade. Other things that can affect your grade are family matters. Family can affect your grade. Job can affect your grade. Friends can affect your grade. So many factors, they can affect your grade. There is one particular person, she never travels unless it is time for my lecture. Doc, I have to travel to here. I have to travel to there. I have to travel to there. Travel is another thing that can also affect your grade positively or negatively, depending on how you look at it. So all other factors can also affect your grade, but haven't been captured. The same thing, the UI will list a lot of other factors that can affect the dependent variable, but haven't been captured. There are several names for this error term. Who can give me another name for the error term? Don't Google it. Don't chat it. What is another name for the error term?
Oh, is it beta?
No, there's another name for the error term. It's not beta. There's another name for the error term. If you check past questions, I asked you this question. That list 6 other terminologies for the error term. What we are studying here today is not a joke. You go to the exam and then you start saying that what kind of question did I answer? Meanwhile, we were treating all of them in class. Yes, Sam.
Well, based on the explanation you gave, if you say deviation, is it correct?
No, it's not deviation. One name of the error term is systematic error. Okay. Systematic error. Another name is an idiosyncratic error. Idiosyncratic error. What is another name of the error term? The disturbance term. Disturbance term. That is another name for the error term. What is another name for the error term? Another name for the error term is a random noise. Random noise. What is another name for the error term? White noise. What is another name for the error term? Residual. Residual. Write it down. Residual. The residual. What is another name for the error term? Idiosyncratic error. I think I mentioned that. White noise is another name for the error. And finally, unobserved heterogeneity. Finally, another name for the error term is unobserved heterogeneity. Very long word, but captures a lot. So these are the several names of the error term. What do the error terms do? What does it capture? The error term captures other factors that can affect the dependent variable but haven't been captured in this model. That is what we mean by the error term. Fantastic. So this is what we mean by the simple regression that we've spoken about. Now, let's look at another kind of regression, and that is multiple regression. Multiple regression. Who can tell me the main difference between the simple and the multiple regression? Even as you see on your screen. What is the main difference you can spot between the multiple and the simple regression?
Well, there's multiple independent variables.
There are multiple independent variables, such as
X1, X2, X3, X4, X5.
excellent. So that's all. That is all. When these independent variables, some of them are D. Suppose we know that, the X2 is actually not X2, but it's rather D2. And that the X4 is actually D4. What does a D mean? The D means dummy. Dummy. And what does that mean? It means that that column variable is a categorical variable. That's what it means. You remember categorical variables, they are not numbers. So you can have a regression model or multiple regression model that has dummies. And in such a case, the model is known as dummy variable regression. Dummy variable regression. Other than that, they are always metric. Very good. If you don't want to write all of these independent variables, you can combine all of them together, like xj. And then you have a complete generalized multiple regression model. That's it. Okay, we are learning the theory first before we get to the practical. Now, another regression you can have is polynomial regression. Now, if you look at the polynomial regression carefully, and you compare that with the multiple regression, what do you see as the main difference with this polynomial regression? Remember, the multiple regression is this, there. Okay. And now you look at a polynomial regression. What do you observe there? What is a clear difference? The first main difference is that a polynomial regression have got squares. The independent variable have got squares. That's all. They have squares, sometimes cubes. And this kind of regression is known as a polynomial or quadratic regression because it's got some quadratic terms. It is a polynomial regression. You can also have a kind of a regression where the dependent variable is rather two, like yes or no, male or female, NDC or MPP. And that kind of regression is binary or logit or logistic or probit or two-bit regression. Write it down, write it down. Okay. So you are binary or censored or logit or probit or two-bit regression. All of these are examples of binary classifications. So there are several kinds of these regressions. Now, I'm going to give 2 marks to anybody that will really be able to give me the answers to the following. What you see on your screen are linear regression models, real ones, real ones. Your job is to tell me other factors inside the error term that have not been captured in the list. So let's take an example. Here we have the wage equation, wage model. And this wage is a function of your education. Your wage is a function of your experience, your position, and your ability. With this, there are other factors that can also affect your salary, your wage. But have not been captured in this model, but they're all hiding, latent inside the error term, the error term. Who can tell me relevant factor that is inside the error term? Who can give me one? Oh, don't worry, I determine what is relevant. Please rename yourself so that I don't address you by, mobile phone names. So who can tell me? Okay. 2 marks. What other factors can affect the salary that have not been captured here? And please, nobody should talk about environment or lifestyle. Let's start with divine.
Competence.
Sorry?
Competence.
Competence is inside your experience and your ability. Albert.
Hours of work.
Hours of work is all part of everything. It is hours of work that is the reason why the salary is being paid in the first place. There is no salary in the first place if there is no hours of work. Think beyond the original and tell me what other factors can likely, Michael.
Your profession.
Everything here is profession. Bernard.
The organization that you are working in.
You mean the type of organization?
Yes.
I'll buy that. So that's the first 2 marks. The type of organization. If you are in the air hosting business or organization, if you are in the mining, your kind of wage will be different from, generally different from those that are in a different sector. So the type of work, yes, can cause that. Prince.
Your responsibility.
Responsibility goes into your position. It's part of your position. Next, Mary.
Gender.
These days, they don't count. Next, Emmanuel.
So the company size or the company size and profitability
No.
at the end of the year.
No. And your name?
So what about location?
Well, how okay, you're going to say, what if everybody say, what about this? What about this? What about this?
No, this is my second one. Location.
I'll come and call you. Whether you have one, you keep your hand raised. I'll come and call you. And your name?
Years of experience.
Experience. And your name, it's like you are not here. On your screen is experience, and then you say experience. Okay, Sam.
Performance rating.
Performance rating is part of everything, including ability. Mary.
Boss, sorry. What about labor market demand?
Labor market demand is a kind of a forces of demand and supply. So there's no speciality there. So no, it doesn't affect your wage. Okay. So let me see if I can get one more person and then I'll quit on this. Prince.
Of your connection.
No. Gordon. To honor connection. That's what you do to get salary.
The salary structure.
Salary structure, no. All right. So one of the things you can do is, Esther, what?
Benefit and allowance.
No.
Doc, what about discrimination?
No. All right, so one of the things you will need is location. Location can affect your wage. Another, please, let me finish.
Doc, I think you said we should say location.
No, I said location.
Yes, we said it into the air. I didn't call you. I remember very well.
No.
I know exactly what I'm doing. So
Doc,
don't
government policies.
Please, I have finished. Let me now talk. You've had all the chance in the world.
Good.
So you have location, that is one. You have overtime. Overtime can change. Excellent. And then you have governmental regulation or government policy, like taxes and subsidies. They too can affect your. Let's go to the second one. The blood pressure of a person can be affected by the age of the person. It can also be affected by the weight, the stress, the exercise level, the smoking status, and the body mass index of that person. For 2 months, there are other factors that can affect the blood pressure of a person, but have not been captured here. Just raise your hand and tell me one particular factor. And again, I will determine whether the factor you will mention is correct or not. Nobody should mention broken heart because it's not part of this. Let's start with Bernard.
Genetics.
Genetics, excellent, 2 marks. Let's note that down. Frank.
Race.
What?
Race.
What is that?
Whether you are Hispanic, African, American, or...
Yes, but these things are very, very not necessarily the case, even though occasionally they may pop up. Okay. So I will not take that one. Emmanuel.
Said diet.
Diet, excellent, very good. And so nobody should mention alcohol, or drug, or anything that enters through your mouth. We'll classify all of those as diet. Excellent, Emmanuel. That is good for 2. Let's go to Alex. Alex Asareba. Prince. Prince.
Prof, medical condition.
Excellent, very good. Other diseases, other medical condition can also affect, whether it is, things like diabetes, things like, stroke, other diseases can affect. Konadu.
Hormonal changes.
It's all part of all of this. Okay? That hormonal changes is all part. But there's a word that you have not mentioned, the better one. Who can tell us the last one? There's the last thing there. Ajua, is your hand still up?
Yes, gender.
Gender. No, I will not buy that. Let's go to another person. Please,
Can I try?
Ajua, we are not doing cha-cha. We're not doing cha-cha. Don't be saying so many things. You have a chance, and then you have to do that. Mary.
It's an old hand.
Sorry?
It's an old hand, but let me try this.
No, please, don't try. It's not, you're not doing that.
What about
please, I say stop. See, you're not ready. Now you're trying things. If it's an old hand, just lower it. When you're ready.
Hello, sir.
Don't worry. If your hand is up, I'll call you.
Hello, sir.
Ajua, if your hand is up, I'll call you. So raise your hand before you hello, sir. What is it?
Okay, so with the gender, there's a woman who gets...
No. You will come to the explanation. I know what you're trying to do. And I'm saying that it's not gender. So I know.
Okay, sir.
I've been teaching this.
Okay.
I'll tell you the answer very soon. Albert.
So, environmental factors.
Yeah, that's it. Right.
My hand is up.
That's it. Okay. Now let's go to finally Sam.
So what about race or ethnicity?
No, somebody just mentioned that. Okay, so the word is pregnancy. Is that not what you wanted to say, Ajwa? Pregnancy. That is what you should have said. We shouldn't have said gender, because it's not any woman who gets pregnant. Okay, it's not every woman.
And dog, that was what I also meant when I said hormonal change.
Yeah, again, I knew that that's what you wanted to say, but that is not, because it's not every woman that has, because some women have not given birth, but they still have hormonal changes. And some men even have hormonal changes. And that does not lead to blood pressure because of that. It is a pregnancy. That is what actually leads to high blood pressure. All right, let's go to the last one for today. The last one is the quantity demanded of a commodity. Again, you want to think. The quantity demanded of a commodity is affected by the price. Okay. It's also affected by the income, whether the good is a normal good or inferior good. The change in the income can affect the quantity demanded or the demand. It's also affected by the price of substitute. It is also affected by advertisement. Usually when there's a lot of adverts, the demand will rise. It is also affected by the price of complement. You see, the way I'm highlighting these things, somebody will come and repeat the same thing. It is also affected by the population. The population. Of course, there are other factors inside this error term that can affect the quantity demanded of gym bitters. Nobody should mention taste and preferences. So tell me one particular factor that can also affect demand, but has not been captured in this model, but is hidden inside this error term. Let's start with Mary.
Dog, seasonal factors.
Excellent. Seasonality. Seasonality. You see, when the thing is good, it's good. Okay? You can lower your hand now before you said that it was an old hand. Let's go to Albert Miama.
It's a consumer expectation.
Not really consumer expectation. That is not the right one. Think and come back again. In the interim, lower your hand. Gordon.
Prof, demographic factors.
No, we will not use that to judge. Okay, you got to be very specific than being general. So lower your hand and come back again. Prince.
Prof, taste and preferences.
Yo, what do you turn out? Let's go to Shack Boy. You see, I told you that some of them were not listening. Okay, Shack Boy. Agbeko. That's it.
Prof, Shark Boy, government policy.
Agbeko. You see, I called him many times now. Whilst I've gone to Agbeko.
Macroeconomic factors.
Sorry, Agbeko.
Macroeconomic factors.
Macroeconomic factors. If everybody should say macroeconomic factors and start listing them, do you know when we will ever finish talking about them? Everything here is specific, but you are generalizing. Let's go to Michael Jomo. Michael Jomo.
Price controls.
Price controls. No, I will not buy that. It's too complex to even deduce. Let's go to Schaefer. Schaefer.
Taxes and subsidies.
Taxes and subsidies. Very good. Taxes and subsidies, which is government policies. Very good. Excellent. Okay. So that's 2 marks for you, Schaefer. Let's go to the next person. Please lower your hands. Those that I've called. Sam Ajuman.
Of brand loyalty.
No, we will not buy that today. Not at all. Let's go to the next person, and that is Divine.
Speculation.
What?
Speculation.
What is that?
Speculation that prices will be going up or there will be shortage.
And he said the name is what?
I said speculation.
Speculation. Oh no. No, you don't mention the right word. Come back again. Think of the right word. Sam, I've called you already. Okay. Yes, please.
Expectation of future price.
Excellent. That's what he wanted to say. And instead of saying that future price expectation, he now says speculation. Okay. That is the correct one, Prince. That is a 2-mark answer. And finally, let's go to Mary.
Those marketing and advertisement.
You're that's it. Okay. All right, so that's it. Okay. You see, we have already been shown that nobody should mention advert. Even though it's here, she still went ahead and mentioned advertisement. All right, so what do you sense in this? If you check carefully, you see that anytime there is a specified regression model, and please write it down because there's a question on this in the exam. Anytime there's a specified regression model, there are other factors in the error term that could be mentioned. But if you check my last year, I asked them to mention 6 factors, away from what was given to them. You will get the same thing. Okay. Now, I want you to note the difference between the first bullet, which is the wage model, and then the last bullet, which is the wage equation. They are all different names. So take note. The first one is known as the specified regression model. Write it down. Write it down. You will understand why I said write it down. The specified regression model. The second one, the last one here, is the estimated regression equation. Estimated regression equation. Now, I want you to look hard at the bullet 1, the specified regression model, and look hard again at bullet 4, the last bullet, which is an estimated equation, the regression equation. There are 2 major differences between the two. There are 2 major differences between the estimated regression equation and the specified regression. Raise your hand and tell me all the 2 major differences, not one, but the 2 major differences between the specified regression model and the estimated regression equation. Ooh, raise your hand and start. You have to look hard. For 15 years, every class has been giving me an answer to this question. So this should not be the last chapter of a class that would disappoint the trajectory. There must surely be some smart people in this room. Surely, there must be some smart ones. Gordon.
Yes, Prof. So for the specified regression model, it is specific. But then for the estimated regression model, no, the specified regression model is not specific, but the estimated regression model is specific.
What do you define as it's not specific and it's specific?
Okay, so the specified regression model has other elements that are encapsulated or embedded within the model. But the estimated regression model, like like the other factors that we were actually talking about, organization and all of that. But for the estimated,
the name for this.
You said?
You don't know the collective name for these factors.
The collective name.
Yes.
You said specified regression model.
Yes, I know. You are saying that it has some other things, that are, not specific. And I'm saying that what do you mean by the other things that are not specific? You see, I'm helping you too much. See the way some people raise their hand.
So we can okay, so the idiosyncratic errors.
And those ones you were looking for, you couldn't get anyone than the bigger one.
Yes, that is what I took notice of.
All right. Okay, continue. Somebody helped you too, so it's good. So continue.
Yes. So the estimated regression model, it is straitjacket. There's no other factors that are affected by
Mention
the
the name.
independent.
Stop using other factors. Mention the names.
So okay, so it doesn't have error terms, embedded in it.
Mm-hmm. And then the second.
Okay, is it for you said the first one and the fourth one?
Hey, Master, I thought you would have put your points together before you raise your hand. So come back again. Let's go to Sam Ajiman.
Yes. Doc, can we say that for the specific regression model?
What do you mean by, I didn't use the word specific regression model. Remember when I was explaining, I said write their names down.
Yes.
So use that.
Okay, I'll come again.
Yes, I like that. Come again. Mary, let's go to Mary Konedu.
So, Doc, the specified regression model has an error term.
Mm-hmm.
And then the estimated does not have an error term.
Mm-hmm.
Yes, so the difference is the error term.
Yeah, that's one. I said two major differences, not one major difference. And you need to tell me all the two. Anyway, thank you for your contribution. Let's go to Divine Hazel. Divine.
Yes, sir. The first one has to do with the error term, which
please mentioning the names of the models you're talking.
Okay, the specific one has error terms.
Which one is a specific one? I didn't use the word specific.
Specified regression. Yes.
Mm-hmm.
That has error term. And then also, I think it's using symbols compared to the estimated, which uses numbers and doesn't have the error terms.
Excellent. That is an answer I'm looking for. That's 3 marks for you. That is 3 marks for you.
Thank you.
By the way, this is an exam question. I just asked you guys. So take note on how you learn everything. The entire exam question is all on this topic. So it's very important you are mastering it. So the specified regression model has no error term, but the estimated regression equation has, the specified regression model has an error term, but the estimated regression equation has no error term. Second, the specified regression model has beta parameters. It has beta parameters, Greek parameters. But the estimated regression equation has numerical coefficients. Write it down. The estimated regression equation has numerical coefficients. These are the two main differences. We'll come back to them in the next 2 weeks. Let's go to the next one. The next thing is to look at the assumptions of regression. Assumptions of regression. What is regression? Regression is the statistical technique for investigating the causal relationship between variables. The causal relationship between variables. The major variable is a dependent variable, and the others are independent variables. Now, for a regression to work well, certain things must be in place. And those certain things are what we call assumptions. I will ask you this in an exam. So it's important you follow. Assumptions are certain things that must be in place for certain things to work. For example, if I should say that the University of Ghana is running right now, it means lecturers are there. It means the board is clean. It means the computers are ready. It means the students are there. It means, the car park is set. So I have already made an assumption before saying that the University of Ghana Business School is running. The same way, if you want to do a regression, certain things must be there in the first place before certain things can work. What is that? Let's start. The first thing for a regression to work is known as linearity. Linearity means that the relationship, the dependency between the dependent variable and the dependent variable must be linear. It must not be quadratic or any form of curvilinear or nonlinear. It must be linear. Now, what do we mean by that? It means that the relationship can be a downward sloping curve, that is linear. Upward sloping curve, that is linear. 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 The relationship must be linear. It must just not be that. It must not be quadratic. It must not be U-shaped. It must not be multiple quadratics. That is the first thing. It must be linear. Number two, in a regression, you have a relationship, and that relationship is established provided you are able to reduce the error term. Now, we've spoken about the error term a lot today. The error term is an error between the actual and the predicted value. So let's say that we are talking about the quantity demanded of gym bitters. This is actual value. And then we go and estimate the model. We get a different value, kill cap. Kill cap is the fitted value. It is a desired. It is a predicted. Write it down. You forget. Once you have that, let's say that the quantity demanded of gym bitters for the first shop is 120. But then you check the predicted is 118. That means that there is a gap between the actual and the predicted. And that gap is what? You can tell us the gap. What's the value of the gap? 2. 2. Okay? And that is 2. And that 2 is the error. So the error for that particular shop is 2. Okay. The rule is that, and by the way, some of the errors are going to be negative, some are going to be positive, okay? Some are going to be 0, some are going to be negative, some are going to be positive, and all of that. The rule of normality, listen carefully, normality says that the expected value of the error term must be 0. Write it down. The expected value of the error term must be 0. Write it down, write it down. What does that mean? It means that the mean of the error term must be 0. What does that mean? It means that the average of these errors must be 0. We'll test that. You see, errors are bad. Errors are not good. And your goal is to have the smallest error, probably even the lowest error. And the lowest error is 0. So regression says that check whether the errors are normally distributed. If the errors are normally distributed, they must be distributed, okay? They must be independently and identically distributed with a 0 mean, a 0 error, the 0 mean, and a constant variance. So the 0 mean is what we talk about as normality. Remember, the errors are stochastic, means the errors are normally distributed. Stochastic is another word for normality. In other words, the errors are not skewed, but they are stochastic. They are normally distributed. So it is about the errors. The other assumption is also about the errors, homoscedasticity. Write it down. It simply means that the variances should be homogeneous. The variances between the errors must be homogeneous. The variances should be constant. That's another way. They should be constant. What is the variance? The variance is more or less a deviation from the mean. That's the variance. A deviation from the mean. So the variances of the errors must be constant. It must follow a pattern. It must follow a pattern. That is another assumption. The third one, or the fourth one, is that there must be no autocorrelation of the errors. There must be no dependency of the errors. In other words, the error between one shop and another shop must not depend on each other. The error should not be dependent. For example, if a student is in the class and that student fails, that failure of that student should not cause another failure to also happen. Another, because you failed, your friend is failing, and all your friends are failing because you failed. It shouldn't be that. That is not good. The errors must not be dependent. They must not be autocorrelated. No, they must be orthogonal. They must be, that's another big word for talking about the errors. The errors must be orthogonal. They must not be related. They must not be related. They must not be related to each other. The covariance between them must be 0. This one said no 0. It must be 0. And then the last one is no high multicollinearity. No high multicollinearity. In other words, the independent variables, please note, multicollinearity is about the independent variables. Write it down. Multico is about independent variables. Autoco is about the errors. I've asked this question many times. Multico is about the independent variables. Autoco is about the errors. Autocorrelation is about the errors. Multicollinearity is about the independent variables. By the way, what is multicollinearity? Multicollinearity exists when two independent variables are so highly correlated that it becomes difficult to separate the partial effect of one from the other on the dependent variable. Multicollinearity exists when two independent variables are so highly correlated that it becomes difficult to separate the partial effect of one from the other on the dependent variable. What does that mean? By the way, this is the time you should start opening your book to Excel as well as opening your R Studio. Get that ready, please. Okay, what is multicollinearity? What does that mean? Well, let's just assume that you are a couple. Your husband has gone to steal huge sums of money on the 24th of December. It was $30 million. And then your husband is arraigned before the High Court, and you were asked, because your husband did say that he was with you the whole day, he didn't go anywhere. So you have been asked to do something about this, to come and testify whether your husband is telling the truth or otherwise. Question is, if you love your husband, which I think you do, unless you are strange, you are likely to repeat the same thing the husband has done because the two of you are multicollinear. And so the judge, the jury will not be surprised that you corroborate what your husband is saying. You just corroborating. But the thing is that it's not surprising because the two of you are too correlated, highly multicollinear. And this is a typical example of multicollinearity. Now, we don't want that to happen in a regression. When you have two independent variables, they mustn't be multico. In machine learning, we solve this by using several beautiful models other than the standard regression model. Good. Now, let's go back to our Burkutu data set and let's exemplify and apply all this. Please, if you have opened your your R Studio as well as your Excel, raise your hand. And please don't lie. I can ask you a question to show you something, and then when you're lying, it's not good. So let me see by hand those of you who have opened their R and the R Studio. Raise your hand if you have opened it. If you have opened your R Studio, as well as if you have opened your Excel, kindly raise your hand. Esther Obriabwa is the first person who has done that. Next. Next. Tracy. Tracy has also done it. Please keep your hand up. Please keep your hand up. When you have raised the hand, please keep it up. So I have some people who have done it. You will appreciate this towards the end. Now we're going to do something. By the end of what we've done today, you will notice that you should have participated in what we did. All right. So please lower your hand and let's begin. So the first thing you're going to do is you're going to do something interesting. Go to your Excel. This is your Excel. And this is about a data set. Okay, let me just give you a bit of information about the preamble. You are writing a journal paper or a thesis or a project, a long essay, a dissertation, whichever way you want to call it. And this is the title of your paper: Determinants of Demand in the Alcoholic Beverage Industry in Ghana. The Impact of Location, Occupation, and Religion. This is your title. After careful scrutiny of the literature, you've already created a tabular taxonomy of the literature. You've surveyed the entire literature. You've downloaded about 100 papers. And you have made some couple of arguments that majority of the previous studies have not considered the effect of location and occupation. In fact, you were even able to justify that with references. You also argue that those that have looked at religion, few of them have actually considered Christian and that even to your best of your knowledge, none of them has considered Buddhist when they are ever looking at religion. You've done a lot of deep research. You may have even gone ahead to identify other gaps. Maybe you've seen studies that have used ANOVA and not regression, which is what you want to use. Cool. From the gaps, you have actually written your contributions of your study. You have defined clearly your objectives. Your questions are spick and span. You've critically reviewed the literature. You have poured all the theoretical and empirical review of the literature. You may have even developed a conceptual framework of a chart deductible from the theories you have accumulated. You may have combined eclectic paradigm, suffocated the logic behind the institutional and the stakeholder theory, combined the principles of agency conflict and signaling. You have associated yourself with a resource-based view of the firm. energize your mental disequilibrium status to an equilibrium and come out with a beautiful theoretical underpinning to support your hypothesis. You've done some great work. And you've collected sample data. And that sample data is what you're going to use to address your question. And this is the sample data. In the sample data, you have a column which is the quantity demanded of gin bitters for every shop. You have that. You have that clearly. And then you have the fact that this quantity demanded is affected by the price of the gin bitters. You also believe that the quantity demanded is affected by the complement price, okay, the complement price. Now, quantity demanded of gin has got complement. For example, sometimes you take gin bitters with kebab, you take it with lime, you take it with beer, you take it with Guinness and other things. So you have the complement price here. And then you also have the income, the average income of the people around the shop, okay? So if you have shop in East Legon, shop 1, then the average income is something like that. Nima, the average income is like, so you have some shops. And some of these shops are located in an urban center, others are located in the rural areas. You have even collected data on the occupational categories of the people. If some of the people are mostly teachers or fishers or traders, you've collected data. In fact, you even know the religious situation of most of the people in the shopping area. Now, I have some series of questions for you because this is an exam question I will also be giving you. Looking at this data right now, which one of these column variable is categorical and which ones are numerical? Who can tell us? Who can tell us? Which ones are categorical? Which ones are numerical? Quickly. Here, you don't delay. Every question I ask you is a question that is an exam and therefore requires a reward. Beatrice.
Location is categorical, occupation and religion.
Excellent. 2 marks for that. So clearly, you know what categorical is at this stage. Now you have filled the data set, you've gone there, okay, and then you can see clearly. Now, let's go back to the scenario. Let's assume that you've collected this data set and now you have all of this information. You can code the data set. So when you look at the Excel, there is a sheet called Brukutu Excel. It is the one where I have coded each of the numbers according to the categories. It's the same categories, but I've just coded them. I've created dummies. We'll talk more about the dummies, but note that it is the categorical variables that you create the dummies from. Write it down. We create the dummies from the categorical variables. Okay. Now, looking at this entire set of work, yours is to do some few things. First, we are going to do some few things in Excel. So go to your data set and follow me. I want you to look at the very top. You see data tab at the top. Data tab. Data, this one, data. When you click on data, look on the far right, you should see data analysis. You should see data analysis on the far right. If you don't see data analysis here on the far right, you let me know. You open your mouth and let me know. Within 20 seconds. Within 10 seconds, you should let me know.
Yes, Prof. I don't have data analysis on my...
Okay. Who else?
Prof, me too.
Prof, me too.
Within the next 1 minute, follow me rigidly. You should get data analysis. 1, click on File on the far top left. File on the far top left. File on the far top left. Scroll to the very bottom left and you will see options. You will see options. You will see options. I'm going faster, so follow me. You see options. Click on options. Then a pop-up will show. This is the Excel parameter dialog box. You see that here. On the far left, under the pane, the far left pane, you will see add-ins. Last but one, you see add-ins. Before the trust center, you will see add-ins. Click on add-ins, and in the list, okay, in the entire list, you should look for analysis toolpack and click on analysis toolpack. I'm not talking about analysis toolpack VBA. No, I'm talking about the analysis toolpack. Click on it. It will turn white or blue. It will turn white or blue. Okay, analysis toolpack. Now come down and you see manage Excel add-in, and you see a little box known as Go. You see a little box with the name Go. Click on Go. When you click on Go, a pop-up will show. And in that pop-up, you will see analysis toolpack. There's a little box to the left of it. Tick that box. Tick that box and click OK. Tick that box and click OK. You should see data analysis now on the far right when you click on the data tab. Those of you who said no, did it work?
Yes, please, Prof. It worked.
Yes, it worked. Thank you.
Thank you.
Now let's proceed. You click on now your data analysis. Click on data analysis on the far right, and a pop-up will show. Look through that pop-up. We are going to select descriptive statistics. Is the first thing we are going to do. Click on descriptive statistics. Yeah.
Doc, I still don't have the data analysis.
And then you probably didn't follow what I said. Did you click at the top of the data tab to be sure?
Yes.
Yeah, I know you didn't follow because I was moving faster. You know, when I said you should tick the box, you may have clicked on the word analysis toolpack instead of ticking that box.
No, I ticked the box. It was correct.
Which are you using MacBook?
No, I'm using Windows.
It should work fine.
So what now? I have analysis toolpack VBA.
Which one do you think I said you should click?
Analysis toolpack.
Good. So you click that, you come down, you choose Go. And then the pop-up comes, isn't it?
It still hasn't popped up.
So the pop-up has not come, but the first time it came.
No, it didn't come the first time too.
But you told me that, you know, you tick the box. So it's the fact that the pop-up didn't come. So how come you could have ticked the box?
No, the pop-up comes from the options, then to the add-ins, and then to the analysis toolpack, and then the manage, and then the Go. So that when you click the Go, then the pop-up comes. That's when you have the interface that,
like what you see here.
Yes.
And you mean what you see here? You don't see analysis toolpack like here.
No, I see analysis toolpack.
And
but
you don't
when I click OK, it doesn't.
No, you don't click OK. I said you should click this box first.
Yes,
box?
Yes, I have.
And then when you click this box, not clicking the word, but clicking the box.
Yes.
And then you click OK.
Yes. It doesn't pop up.
Sorry?
It doesn't pop up.
What doesn't pop up?
Data analysis.
Data analysis is not supposed to pop up. You should see it on the far right.
I still don't see it.
Click on the data tab at the top near review.
Okay, it's there.
No, the point is that you didn't click on the data tab.
Yes.
You have taken our life.
Thank you, bro. Thank you.
All right, so click on data analysis, everybody, and choose descriptive statistics. Now follow me carefully. you see an input range will come. Input range. There's a white space to the right of the input range. Click on that white space. Click on that white space. While the cursor is blinking there, you're about to select only the Q to M. So click on the letter Q. Click on the letter Q and drag it till you get to M. Okay, and drag it all the way down to the end. So Q to M and drag it all the way down to the end. As you are going down, you will slip. You might even go past the number. When you do, come back to the end. And now you will see that inside the input range, you will see something like C1 colon F41 in the input range. Don't click anywhere else. Let that be there. Okay. You can scroll up and down, but let that be there. Once it is that, and if you make a mistake, you click somewhere else, you will not see C1 to F41 in the input range. Now, take labels. Take labels in first row. This one. Okay. Take labels in first row. Labels in first row. Take it. And then come to new worksheet. New worksheet. Okay. And then choose click inside the white space. The white space. Okay. Click inside that white space. And then just write a name. SUMM for summary. In fact, you can even type the whole of the word summary. 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 And then after doing that, come slightly down and check the box called summary statistics. Check the box known as summary statistics. And that's it. Click OK. A new sheet will be created at the bottom. Click OK. Like this. A new sheet, like what you see down here, has been created, okay, at the bottom with the name you gave. And inside that sheet, you should now be seeing the descriptive statistics for Q, P, C, and M. We are not done yet. Now, I want you to highlight the Q, drag it all the way to M at the top, and then hold down your control key, or you can right click and cut. You can right click like this and cut, not copy or cut. You cut it and come and select B1, cell B1, cell B1. When you select cell B1 like this, do paste, Control V to paste, or you can right click and choose paste like this. You only shift these
Please, can you go
one
over
time
half?
to the right. Which one should I go over?
After highlighting from the Q to M.
Cut. Cut and paste it under B.
Okay.
That's all. Now, once you are done with that, and the reason why we are doing this is that the same letter is written here. Mean, standard error, median mode. The same thing is here. Mean, standard error, median mode. The same thing is here. So we just want to delete some of them because the same thing, same thing. So you just want to delete this. So click on the C, and you see that just below the C, there is no letter there except mean, standard, median mode, and everything else. Hold down the control key and select E. Hold down the control key still and select J. You see the way I've done mine? And right click on any one of them on the top here, top of J, or top of the E, or top of the C, click on that. And then when you right click, you choose delete. Delete. It's going to delete them. Everything is beautifully organized with the numbers like this. Now you will see that the mean for quantity demanded is 175. You will see that the mean for the price is 15. You will see that the mean for the complement price is 125. You will see that the mean for income is 17.95. That is the mean. Of course, you have other ones like the median, the mode, the standard deviation, the kurtosis, the skewness, the minimum, the maximum, the sum, the count, all of these. These are known as descriptive statistics or summary statistics. I will do something like that in the exam, and I'll ask you some questions. In your assignment, you will do something like that yourself and address some questions. Okay. Now, before I come to the questions, we are going to do the same thing in R Studio. So follow me. We're going to go to our R Studio. So go to your R Studio here. And normally when you start with this R Studio, you will see that everything is empty like this. Click on number one. Your cursor must be blinking at number 1. And then type the following. In fact, whatever we are going to type is already in your slides. When you scroll down a little bit, you will see that. The first thing we're going to type is the bullet number 1. Okay, so now let's begin. So what are you typing? Type the following. Jim equal to read dot the lane, and when it pops up, just select into bracket, double apostrophe. Inside the double apostrophe, type clipboard. That's it. And you can give an instruction. Instruction is bringing a hash symbol and then writing something for you to remember what the code is about. So this code actually, this code imports data from Excel using the clipboard. Using the clipboard approach. So you just type something so that next time you remember it. That's it. So this command requires us that we go to the Excel and bring the Brukutu data from Excel to R. R is a very powerful software. It can even draw your face. It can be used for movies and several things. A lot of machine learning, a lot of AI, a lot of deep learning, convoluted neural networks. Okay, all of these are done using R software. Sometimes some use PyCharm or Python, but this is good. Okay, so let's go to the data set. So we come here and choose Brukutu R. Okay, this will be at the bottom of your data set, the sheet called Brukutu R. Click on that, and then it will open the data set. Oh, by the way, do you guys realize that? Okay, I'll show you when we get. Do you guys realize that when I was doing, in fact, I'll show you later. I'll show you because it's going to show up here very soon. Okay, so now that you are in the data set here, copy the entire data set. You can click inside anywhere and do Control-A to highlight, Control-C to copy. When you copy, it will go on your cursor clipboard. It has been copied onto your cursor clipboard. That is why we are using the clipboard command to bring it here. When you come to the R, click on where you wrote your command. Don't paste it. Never paste. Whilst the cursor is blinking on the command, just look at the top and run. You see run, or you can do Control-Enter to run. You can click run, or you do Control-Enter. It will do the same thing. The moment you run, you come down and you will see that the same thing you wrote at the top is showing down here in the console. Okay? So you see it's down here in blue. It has to be in blue. Okay? And you see it beautifully down there. Raise your hand if you have done that. Raise your hand if you have done that. Good. I've got some great people following me. Keep following. Now, we have gotten the data loaded into R. So what is the next? The next thing is we are going to show the data. You're going to show it. So like to show down there. So how do you show it? Just highlight the gene alone. Just highlight the GIN and run it. Just highlight the GIN alone and click run or do Control Enter. And once you do that, you see the data now showing down here in the console. You see the data, all of it showing here in the console. I know many of you have done that. Now we are ready to do the real work, okay? The first thing we are going to do is we are going to plot some few things. Yes, Prince. We're going to plot some few things, okay? We are going to do something we called correlation. Correlation, okay? But not just correlation. There are other things that we'll also be doing right here. But for now, the most important thing we are going to do for today is summary statistics. Summary statistics. Now, I want to check the slides. It's all there. Okay. To do that, we are going to install a package called require site. Now, of course, there's another summary statistics you can run on your own, but it's not that good because it doesn't give you a lot of details. So we're going to use a better summary statistics. But before we can use that better summary statistics, you need to install a package called Psych. So once you are in your R, on the far bottom right space, far bottom right, okay, this entire space, you will see install under packages. Under packages here, you see install. Okay. Under packages, you see install. Click install. Click install, a pop-up will show. That pop-up, you see the cursor blinking under packages. Type the name of the package. It is called PSYCH. In fact, if your internet is good as you're typing, you see it. PSYCH. Once it comes, select it and install it. Once it comes, select it like this and click install. I have already installed, so I will not install it again. Whilst it is installing, you see something moving, red round, something tiny, somewhere here. You see it, moving. It comes and goes, it comes and goes. Do you see it? It comes and goes. Okay, so now it is installed. And now I want you to go back to the command center here, command number 2, and then type require into bracket psych. Require into bracket PSYCH. Spellings are very important in this command. Require psych. I'm going to take attendance towards the end. So your colleagues that are not here, tell them they are want to be here. All right. So now do that require psych and run it. Do that and run. Now you know how to run. Once you run it, at the bottom, you see something like this, loading require package. Loading required package. loading required package. Okay, so now once you have run that, you come down and type describe into bracket gen. Describe into bracket gen. Do that and run it. Describe, in fact, again, this is in your slide, so you should know it. Describe into bracket gen and run it. And when you do, you see some results here. In fact, I want mine to look good, so I'm going to run it again, and it is well organized. You will see something beautiful down here in your console. Now, let me see by hands if you have done this. Let me see by hands if you've done this. I've taken note of the first 5 people who did that. And I've taken a picture of the first 5 people who did that.
Prof,
And
please,
this,
I'm lost.
don't worry. And the first 5, somebody should say hello on your page for me. Say hello on your page. Say hello. I'm going to put it on the page for the first 5 people. Each one of them has 4 marks. If you came back later, you are not packed. Say hello on the page I am. Okay, so you see it there, and then we have the winners, all of them being shown there. So congratulations, the winners. You all have 4 marks. If you are packed, you know. So ladies and gentlemen, I have some questions to ask you as far as this is concerned. I want you to look carefully at these descriptive statistics here. You will notice that the last information, the last few information, they have been starred. They have been given a star. Who can tell me why? Wisdom at its zenith. Who can raise a hand and tell me, friends, if your hand is not up, lower it, divine, the same thing. Who can tell me why? Esther.
Prof, I want to attempt.
Yes, the attempt is good.
Because the data results for those category are categorical.
Excellent. That is 2 marks for that. Because this is an exam question of which I've asked multiple times, by the way. Okay? Because they are categorical, that is why. And R is sensible to know that they are categorical. So R is actually telling you that don't worry yourself to read the descriptive statistics for these variables because they are meaningless. In fact, that is why you could remember that during the Excel, I did not even generate those variables. That's this one. So on the basis of what we currently have, remember that we have important information. We have the mean, the first one, the standard deviation, the median, the trimmed mean, okay, the minimum absolute deviation, the minimum, the maximum, the range, the skewness, the kurtosis, the standard error. So we have so many information right down here. Now I have a question for you. What is the sample size? Looking at this table, what is the sample size? Who can raise a hand and tell me? What is the sample size in this data set? What is the sample size? Yes, Bernard.
9.
9. That is wrong. What is the sample size, Prince?
40.
40. That is correct. That is 2 marks for you, Prince. Now, 40, what did you get at, Prince?
From the N, looking
Exactly.
at the, yeah.
Column N. What does that sample size here mean? What is it talking about? Prince, totally on you.
Prof, still me. It's talking about the values, or the values that we picked from the book too.
It is talking about the number of shops. You see the first column says shop.
Yes.
And actually, you will also find that from the preamble. Don't worry, it doesn't take out your 2. Okay. So that is a sample size. Now, who can tell me the mean value for the quantity demanded of gin? What is the mean value for the quantity demanded of gin? Who can raise a hand and tell us? What is the mean value for the quantity demanded of Burkutu gin bitters? Albert.
175.
Excellent. And what is the ketosis value for the average income of the people around the shop? What is a ketosis value for the average income of the people around the shop? Abbott.
1.26 minus.
Excellent. 1.26, negative 1.26. Excellent. So that's 2 marks for you, Albert.
Thank you, sir.
So this was the value he just spoke about. Okay. So that matches the M, which is the average income of the people around the shop. Now, the quantity demanded is 75. I want you all to check something. If you look at the quantity demanded, which is 175, and you look at the standard deviation, okay, you can see that the mean of 175 is bigger than the median, is bigger than the standard deviation, which is almost 30. What does that mean? I will ask you this in an example. What does that mean? It means that, and please note this down, whenever the mean is bigger than the standard deviation, it means that the sizes of the observations vary a lot. The observations have varying sizes. In other words, some of them are very big, some of them are very small. Oh, sorry, stop. It means that observations are of similar sizes. The observations are of similar sizes, which means that most of them are of similar size. Neither of them is too big and neither of them is too small. That is it. Take note. Okay. The quantitative questions are all compulsory, so take note. Okay. However, if the standard deviation is bigger than the mean, if the standard deviation is bigger than the mean, then it means that some are too big and some are too small. That's what it means. It means that some are too big and some are too small. Some are too big and some are too small. So take note and read around it. When the standard deviation is bigger than the mean, there is a lot of variability. Otherwise, there is not. So this is how you generate something known as descriptive statistics. Now, ladies and gentlemen, there are some incredible graphs you should learn to generate, okay, by looking into the slides. So you can see that there are some graphs here. Oh, there's one more thing that you should learn to do, and that is, what do you call it? That is descriptive statistics according to groups. So let me give you an example. Suppose you want to check whether the mean of the Muslims, the Christians, and the Buddhists, whether the means are different, like the ANOVA we did. You can use describe by. So just type describe by, and choose the by, the one that is capital B. described by, okay, and then type into the bracket Jin, and type comma, Jin dollar religion, REL. That's it. Jin dollar REL for religion. So what we are trying to do is that we're going to get descriptive statistics for each of the groups. So when you take only the Buddhists, what is their mean quantity demanded? If you take only the Christians, what is their mean quantity demanded? If you take only the Muslims, what is their mean quantity demanded? That's what we are trying to look at here. So run this. And when you run this, you will get a beautiful, beautiful descriptive statistics. See here. Okay. I'm just showing you everything. You will notice that the descriptive statistics is here. We have only for the Buddhists, only for the Christians, and only for the Muslims. You have it all there. Now, how many are the shops within the Buddhist areas? How many shops are within the Buddhist areas? Who can see this? Friends?
12.
Christians?
Christians are also 12.
Muslims?
16.
Exactly. Guys, you can learn how to read tables. Now, looking at the quantity demanded of Jembetes, which of these three groups would you say that they are heavy consumers of Agbatesh? Which of them would you say that they are very, very heavy consumers of Agbatesh? Is it the Buddhists or the Christians or the Muslims? Of course, I'll ask you why. Christian. Dampare, your name is Christian. Anybody? I think he is not.
I think the Christians, because they have the high quantity demanded.
What value?
206.67.
206, very good. So that is how you detect clearly. So you see, by just looking at this, you will know. I can ask you which of them. Yes?
Can you also use the mean to determine this?
The mean is what he used. He used the mean, really.
Yeah, I think I.
So it's the mean he used. So you should learn how to read tables a lot because you'll have a lot of these things. Contingency table. You should be able to even create how many Christians are and Muslims are there. Okay. You can create a contingency table. And I have that in the slides. You should check it. In fact, everything I have in the slides, go and check. For example, if you use this command, you can classify all of them across the table. Let's say that you do this. Okay, you run it. Check what you have. This is the last thing for today. You will see that I can ask you a question that how many of the traders are Christians? What answer will you give me? Looking at the table. Sorry, how many traders in the rural areas are Christians? How many traders in the rural area are Christians? How many traders in the rural areas are Christians? What would you say? Looking at the contingency table.
0.
Is 0. And how many Muslims, okay, in the urban centers are teachers? How many Muslims in the urban centers are teachers?
4.
And how many fishes are in this entire data set? How many fishes are there? How many fishes are in this entire data set? It's not 12.
8.
8.
Stop guessing. Beatrice.
16.
16 is the right answer. The people who know are the ones who raise their hands. Those who do chaka 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 chaka, they are the ones who don't know. So watch it carefully. You should be able to. I'll give you this contingency table in an exam. And the one in the exam is quite loaded because there are a lot of the categories also there. So go and look at some of these things in your slide. Next time, we are going to look at something called correlation and then regression. We've learned correlation, but we're going to develop correlation in Excel and develop correlation as well in R. That's it for today, ladies and gentlemen. It's been a pleasure having all of you. If you have a question, please feel free to ask your question.